Artificial intelligence. It's everywhere, right? It feels like it's promising to change, well, everything. But if you get past the headlines and all the hype, what is it really? How does it actually work? And what is it doing for us right now, today? Well, let's dive in and pull back the curtain on the world of AI, all the way from the code that builds it to the cosmic questions it's helping us answer. So, to get us started, let's frame our whole conversation around this one central question. Is AI a tool that we just wield? Is it a partner we collaborate with? Or is it something that could one day replace human effort entirely? Now, the answer is definitely not simple, and by the end of this, I think you'll see why this is probably one of the most important questions of our time. All right, so to really understand where AI is going, we've got to start at the very beginning, with its core blueprint. What is the fundamental goal of this entire field? It's not quite what you might see in the movies.
This concept right here, the rational agent, is absolutely key. It cuts through all the sci-fi noise about consciousness and feelings. See, the goal of modern AI isn't to create a machine that thinks like a human, but one that acts rationally. Think of a self-driving car or a chess program. It perceives its world, and then it takes the best possible action to achieve a very specific goal. That's it.
And this represents a massive shift in the field. Early on, you had the famous Turing test on the left there, which basically defined intelligence as being able to fool a human. But today, the focus is all about rational action, what you see on the right. It doesn't really matter if an AI seems human. What matters is, does it make the best decision to hit its target? Whether that's winning a game, finding a protein structure, or navigating through traffic. It's all about performance over imitation.
And this shift didn't just happen overnight. As you can see on this timeline, the journey started way back with Turing's proposal in 1950, and then the term artificial intelligence was officially coined in 1956. The field saw these periods of huge optimism, but they were followed by these so-called AI winters, where all the funding just dried up. But the real breakthrough, the one that led to the AI we have today, was the rise of machine learning. That's what moved us away from trying to hand-code every single rule to creating systems that could actually learn from data.
Okay, so we've covered the what, now let's get into the how. How are these incredibly powerful systems actually built? What's in the AI toolkit?
Honestly, the best way to think about it is this. If data is the fuel that powers modern AI, then a programming language like Python is the engine that makes it all run. And this is a really crucial point. AI isn't magic. It's built with code, and it is trained on massive, massive data sets. And the reason development has just exploded is because developers aren't starting from scratch anymore. They're using these incredible open-source building blocks. So think of a library like NumPy as a superpowered calculator, Pandas as a brilliant organizer for all that data, and Skitsarn as a toolbox that's just full of pre-built machine learning algorithms. These tools put incredibly powerful capabilities into the hands of developers everywhere, totally for free.
So using those tools, developers can build models to solve all different kinds of problems. And as you can see in this table, they pretty much fall into three main types. First, you've got classification, which is basically sorting things into buckets, like is this email spam or not? Then there's regression, which predicts a number, like what the temperature will be tomorrow. And finally, you have clustering, which is kind of like a detective that finds hidden groups in your data without you telling it what to look for, like figuring out different types of shoppers. The whole point is you have to pick the right tool for the job. Now we get to the really exciting part. With this foundation, what is AI actually doing out in the world? Well, it turns out it's becoming an absolutely indispensable partner in science, and it's pushing the boundaries of discovery itself.
And the impact is just staggering. AI is acting like a supercharged research assistant for scientists. It's running simulations that would have been completely impossible before, designing totally new proteins from scratch, automating lab experiments, and even helping to run our most advanced telescopes. And in fields like physics, it's solving these incredibly complex inverse problems, working backward from an effect to figure out the cause. This is a revolution, and it's happening across pretty much every scientific field.
And for a perfect concrete example, look no further than AlphaFold. This quote really sums it up. It was a standout success. Its ability to predict the 3D structure of proteins was a breakthrough so profound, the science behind it actually contributed to a Nobel Prize. It solved a 50-year-old grand challenge in biology, and in doing so, unlocked a whole new era of drug discovery and disease research.
And this is where it starts to get even more futuristic. We're now seeing the rise of what people are calling self-driving labs. As this process shows, the AI isn't just analyzing data anymore, it's running the whole show. It formulates a hypothesis, it designs and runs the experiment with robots, it analyzes the results, and then it uses that new knowledge to iterate and improve.
This closed loop can speed up the pace of scientific discovery exponentially.
So, with these incredible new capabilities, the question starts to shift from what can AI do to what should we do? How do we build a future where these tools are used responsibly and for the greatest possible benefit?
This brings us right back to that question we asked at the very beginning. As AI becomes a more capable partner, our role becomes even more critical. It's really up to us to guide its development, to make sure it aligns with human values, and to build the frameworks for collaboration, oversight, and ethical use.
To do that, the scientific community points to 4 key pillars for building a healthy AI ecosystem, which you can see right here. We absolutely need education and training, because you can't build the future with tools you don't understand. We need collaboration, because the biggest breakthroughs happen when different experts work together. And of course, you need the resources, that's funding and infrastructure, and the guardrails, which is strong ethical oversight to make sure we're building all this responsibly.
And that ethical oversight has to tackle some really tough problems. Like, how do we understand why an AI made a certain decision? That's the black box problem. How do we make sure the data we train it on doesn't just perpetuate historical biases? How can we be sure an AI model is reproducible and reliable? And maybe most importantly, how do we make sure we're still valuing genuine human insight in an age of AI-augmented everything? These aren't just technical questions. They are deeply, deeply human ones.
So, let's end here. AI is already a powerful tool, a transformative partner that's helping us unravel the mysteries of proteins, of new materials, of the entire universe. But maybe its greatest contribution won't be in the answers it gives us, but in the entirely new questions it will enable and even inspire us to ask. What new frontiers of knowledge will we get to explore together?